This video is all about data science and programming for data science, so let's jump right in. Before we begin, let's look at how we will break things down. There are 3 topics that will lead us to an understanding of data science. We will answer the question, what is data science? And we will do this directly and concisely. After we know what data science is, I will show you a simple and understandable example of a data science project for trading stocks. And we will round things off by getting an idea of how much programming is needed. By the end of this talk, you will be equipped with the knowledge you need to understand what data science is and how you can get started with data science yourself. Data science is an interdisciplinary study of data whose central focus is the data lifecycle and how data is applied to the decision-making process. There are 2 parts of this definition we should highlight. Number 1 is the term interdisciplinary, and number 2 is the concept of data lifecycle. The term interdisciplinary means that data science is composed of multiple disciplines. These disciplines include mathematics, computer science, and what is called the domain discipline. The domain discipline is the field where the decision-making process is being applied. This could be any discipline that uses data. As you might expect, most disciplines qualify here. Some examples are business, economics, finance, healthcare, biology, astronomy, robotics, and many, many more. This fact about data science is why you will often hear about teams of data scientists when working in industry. This is generally the case in interdisciplinary fields since individuals that have all of the necessary skills are rare. These types of rare individuals are sometimes referred to as unicorns. Let's look now at the concept of data lifecycle. The data lifecycle describes data over time, from the moment it is created through all of its updates until it is lost or deleted. So the process of creating, updating, and deleting data is what is meant by the data lifecycle. Data science is a new and emerging field, and arguably one of the most prominent reasons for this emergence is because the data lifecycle for many data sets has been extended by technological innovation. I want you to think of footsteps, for example. In the past, most data around footsteps is lost just moments after being created, a very short life cycle. But now, we have devices that can collect this data, persisting it and extending its life cycle. Longer life cycles like this open the door for us humans to begin creating a science. Let's move this discussion to an example data science project. We will look at an idea for a stock trading project which tells us right away that finance and trading are the domain fields for this particular project. One of the first things that a project needs is a goal or an identified problem that the project seeks to solve. So we'll say that our goal is to create a trading bot that buys and sells stocks based on price data. The structure of this project will have an underlying framework with 4 parts. This framework is general and is typical of most data science projects. We have data source, data storage, data analytics, and the decision. The data source is where the raw data is generated. Data storage is where we store the data and make it accessible for queries. Data analytics is where statistics, machine learning, and artificial intelligence operations are performed. The decision section is determined by the goal and is performed either by humans or machines. This is the data science framework. We call this a framework because it gives us a structured way to do our work. Let's see how our project fits in. Our data source is price data from stock trades. Once we have the data, we must store it, organize it, and make it accessible. Organizing it is necessary because the data can vary in quality and structure depending on who is providing the actual data. In some cases, there are many different possible providers. Providers are the entities that actually collect the data and make it accessible to us. And in our cases, these are exchanges. Once the data is stored, organized, and accessible, we analyze it, producing the information needed to make our buy and sell decisions. There are two ways the buy and sell decisions can be made. The first way is by a human. I want you to think of a team of data scientists providing information to, say, Warren Buffett that guides his buy and sell decisions. The other way is using a machine. And when a machine is making the decision, we usually mean that an app is making the decision. In the world of trading, we would call this a bot or an algorithm, but it's just an app. So the data flows from the source to our storage through our analytics and ultimately informs our decisions on buying and selling. I want to give you some more important details about this framework, so let's see what's up. As the price data is generated at the exchange, the data flows through what we call an ETL pipeline. ETL stands for extract, transform, and load. The transform step organizes and preps the data before it is loaded into the storage system. To do data analytics, we query the data, and analytics produces information that can be used to make our buy and sell decisions. In our example here, and moving forward in this series, we will focus on machines that make decisions, which naturally leads us to programming. So let's get an idea about how much programming is needed at each step in this framework. The edge connecting the first two nodes, source and storage, primarily involves moving data and transforming data. This is done with simple update operations. Once data is loaded into a computer system, code is great at moving it around, and this type of programming is an easy way to learn if you are a beginner. The next edge connects storage with analytics and is all about querying for specific data needed to do the analytics. Code is an extremely useful tool for finding specific pieces of data inside larger data sets. This type of programming steps up a level in difficulty as it involves searching, but with some practice, a beginner can still do it. Next, we have the actual analytics that create the information used to make the buy and sell decisions. This section can be as simple as some basic statistics and move all the way up to full-blown AI. This type of programming steps up another level in difficulty, but it's not a requirement for it to be difficult. It just depends on how sophisticated the analytics are. There is a lot of room for growth in this area if you are a beginner. When the project is ready to be used in real life, the final product is usually a program or application that is deployed to what we call production. This means that the application is connected directly to the data source and begins making decisions in real time. More computer science skills are required here because the application will have to keep track of its state, and this type of programming requires more design considerations that can get sophisticated. And if the product is being deployed in a commercial setting, there are many other considerations as well, like security, for example. And all of these things require more of a computer science background. Remember though, this is for a full-scale production-ready application. The proof of concept application is very doable for a beginner. And you can see here, these are the steps. This is what it takes to code for data science. Now you know what's up. The main takeaway from this video though is that data science is an interdisciplinary study that uses programming and code as one of its primary tools for getting things done. We're talking problem solving using data. Data science is a great place to start with programming if you're interested in data and interested in learning to code. If this is you, go ahead and jump into the data science playlist for programming. It will teach you everything you need to know about code so you can get started at using it in your own data science projects.